Alright, so today it's time to take a look at what exactly impedance means and how it's different from normal resistance. So first of all, let's take a look at what normal resistance means. Resistance is a number that tells you how hard it is for an electric current to get through something. So, for example, if we've got a wire made out of copper, then that wire has a certain amount of resistance, and the higher that resistance is, the harder it would be for the electric current to run through that wire. Now, there is a well-known equation which is called Ohm's law for working with resistance and voltage and current, and it looks like this. And it states that the voltage divided by the current is equal to the resistance. So if you make if you apply 10 volts to something, and you notice that the current is 2 amps, then you know the resistance must have been 5 ohms, right? Resistance is measured in ohms. That's the unit for it. Now, in this equation, I would like to take a look at two things. First of all, the R, right? The R is obvious. That stands for resistance. But we've also got the other side of the equation, which is voltage divided by current. The voltage divided by the current, you could call that the voltage current ratio, right? That's a way of saying voltage divided by current. And that is what we call impedance. So now you might be wondering, well, that's just the same thing as resistance, right? Because there is an equal sign right in between them. And you would be right, because in a normal wire or in a normal classic resistor, the impedance, or the voltage-current ratio, is equal to the resistance. It's the same thing. So if I say the impedance of this cable is 1 ohm, that would be exactly the same as saying that the impedance of this cable, or the resistance of this cable, is 1 ohm. That doesn't matter. So then why do we need the word impedance? Well, great question. Let's say we have something like a coil of wire, okay? Now we all know that a coil of wire generates a magnetic field when you make an electric current run through it. Also, if you change the electric current, that also changes the magnetic field. Now if we take a coil and connect it to a DC power supply, so a constant voltage, this will create a constant current through this coil, and therefore a constant, stable magnetic field around the coil. In this situation, the coil behaves as though it's just a long wire, okay? So the resistance of the coil in this case is still equal to the impedance. Yes, it's wrapped up in the shape of a coil, but it's still just a long wire, okay? So in this case, everything's fine. But you could also connect a coil to an AC power supply. In that case, it would be very different. If you connect a coil to an AC power supply, this creates an alternating current through the coil, and therefore an alternating magnetic field around the coil. And what this does is it adds extra resistance. But we don't call this extra resistance. That would be stupid. No, that would be way too simple, right? No, instead we call this inductive reactance, with the symbol being a capital X. Now, so basically, inductive reactance is a form of resistance caused by magnetic fields. Okay, very interesting. So what we've got now is when our coil is connected to a normal DC power supply, it behaves as a long piece of wire. But when you connect it to an AC power supply, it has got its classical resistance, because it's, after all, it's still a copper wire, and it's also got this inductive reactance. It's also got this additional resistance caused by the magnetic fields. So it's now got basically, this is an incorrect way of saying it, but basically it's got two different types of resistance. Now it's a nice thing to have the word impedance, because now we can say that the impedance would be the combination of these two things. So, if you would say the resistance of this coil, then you're referring to just the resistance of the copper wire that it's made of. And when you say the impedance of the coil, then you're also saying the overall resistance, right? The resistance combined with the reactance. In this case, the inductive reactance depends on the frequency of the AC power supply as well. So the higher the frequency, the larger the reactance. Therefore, the higher the frequency, the larger the impedance of the coil will be. But remember, the resistance will always be exactly the same because that's just the resistance of the wire. But the impedance also depends on the reactance and therefore also on the frequency. So that is basically what impedance is. Impedance is a more complicated overall version of resistance that refers to the combined resistance of a thing. So not just the resistance of the physical wiring that it's made of, but also things like inductive reactance. Well, anyway, I hope you've enjoyed this video, I hope you've learned something, and thank you for watching.